Good afternoon, everyone. I'm Tinashe Wagoneka, and with my team here, got Anesu, Usipe, and Laim, and we are going to present our innovation, which we did during the winter school, which is called SADC Hydro Twin plus Internet of Things Groundwater Data Sharing Platform. We are moving with the theme transforming groundwater data into shared intelligence across SADC region. And just to add on to that, this work aligns with the theme of this conference, which is investing in groundwater for climate resilience, in that it improves monitoring, cooperation, and decision making across transboundary aquifers. So moving on, groundwater is a major water source which is used across the SADC, which is mostly used across the SADC region, and it is scarce and it is not being monitored. And I think it has been emphasized in almost all the presentations that were being done. So the problem is that there is fragmented data across the region, and it is across the fragmented data that is there. It is across institutions which are in different countries, and it is often outdated, and in many cases stored in formats that are not easily shared. We still have very limited real-life monitoring systems. Much of our data relies on manual collection and manual entry, which results in delays and inconsistencies. In some cases, there is lots of critical information. And these challenges do not only affect national planning, but also weaken coordination across shared aquifers, especially where water crosses borders. And to solve these issues, SADC-GMI came up with a good idea to counter this, which is the SADC-GIP, or the SADC Groundwater Information Portal. But the portal on its own has got some shortfalls, which we tried to address with our innovation. Firstly, the system still depends heavily on manual data entry and delayed validation, meaning updates are not always timely. Secondly, the portal does not support real-time monitoring or automated alerts, which limits our ability to respond proactively to events like drought or contamination. In addition to this, many data sets are presented as static layers with limited visualization, making it difficult to analyze trends and also to model future scenarios. I will leave this time to the next presenter.
Good afternoon. My name is Laimi. I'll take you through the proposed innovation idea. This idea is fully integrated data sharing system, which uses advanced technology to enable groundwater monitoring with secure, role-based data sharing across SADC. It has four components, which is the Internet of Things monitoring nodes. This consists of the Internet of Things sensors. These are our eyes on the ground. They are collecting real-time data on water level, water quality, and abstraction rate. And they are embedded in the monitoring wells within the aquifer. Then we have the regional digital twin. This is the brain of the system. It uses artificial intelligence and machine learning to integrate Internet of Things data with those of historical data and satellite data. It also simulates drought and contamination scenario and uses GIS for spatial analysis and comparison. Then we have a SADC Groundwater Data Sharing Hub. And this is a cloud-based data platform with secure role-based access. It enables countries that are sharing an aquifer to upload and access each other's data. And this is just an enhancement to the existing SADC-GIP. Then we have a governance framework. This is a SADC-wide protocol for data ownership, access, and compliance. It ensures the tiled access, which means different users like SADC-GMI, national authorities, researchers get different level of access to the data and dashboard based on their role, responsibilities, and authorization. Here is the innovation flow diagram. It shows how the data flow from the sensors to the end users. Sensors, these are the Internet of Things, multiple parameter probe that measure water quality, a pressure transducer that measures the water level, and the flow meter for the abstraction rate. And the data captured with these sensors are being recorded in the data logger. The data logger converts these readings into engineering units and filters out the errors. It also packages the data for transfer. The data is being transferred using its cellular and satellite communication technologies. And the data is being transferred to the clouds. And during this transfer, the data is encrypted for security. During cloud ingest, this is where the raw data from all member states are received and permanently stored. The data is then being processed and checked for quality. This is by artificial intelligence and machine learning. They apply calibrations and validate data. They also check for wrong values and also for duplication or missing data. And this quality check data is then being provided to the digital twin. And during data integration, the digital twin uses the artificial intelligence to integrate Internet of Things data, historical data, and satellite data. It also now simulates the contaminations and drought scenarios. This data is then transferred to the dashboard. And this is a real-time dashboard that displays live readings, simulation, tests, and arrays. Then this data is being accessed by all the end users. These are the water managers, the researchers, policymakers, SADC-GMI, with login details and technical setups. They'll be able to view live displays, and they'll be able to download the data or reports. The uniqueness of our innovation idea. This innovation idea is truly unique as it's Africa's first regional groundwater digital twin. It's capture real-time data and predict modern integration. It's secure, transparent, and built on trust and openness. And the artificial intelligence and machine learning here, they automatically interpret data and communicate them in local language for all users to be able to understand and have insight on what is happening.
Good afternoon, everyone. My name is Usipe Kotongwana. Our study area for our data is the Stamford Transboundary Aquifer, which is shared between Botswana, South Africa, and Namibia. There are approximately 6,000 boreholes across the three countries. Majority of the boreholes are production boreholes. The impacts and benefits of our innovation there's categorized according to 4 components, which is the environmental. Under environmental, our innovation will help to track the depletion of groundwater and then support sustainable use. Under social, there will be early warnings for communities, early warnings of drought, contamination. This will help address the climate change issues that we are facing. Under economic, it will help to reduce duplication and guide investments. And then under regional cooperation, it will strengthen water diplomacy. We have operation, maintenance, and sustainable plan. Our sustainable operation and maintenance plan ensures a reliable operation through clear roles, standard procedures, local capacity development, and long-term and financial environmental resilience strategy. Thank you.
Bonjour. I think I'm going to be actually speaking French after this this conference. My name is Anes Ugonye and I'm from Zimbabwe. I'm a young professional for SADC-GMI and I am actually an environmental engineering professional. So I'm actually going to take you through the implementation plan that we have for our project. It is actually good for us to have a proper plan so that when we are now investing in groundwater projects for action, for climate action, we have got proper plans that will actually ensure us we have successful project implementations. So this Gantt chart is actually showing activities from resource mobilization up to the end of the project. And of course, for a project to be successful, it needs a budget. And this financial availability shows actually our budget, the summary of our budget. And on the top right corner there, you will see an Excel sheet icon that actually shows the breakdown of the whole project, highlighting everything that is in the summary and how we actually came up with the budget. And of course, we have got a funding model that we have. We actually did put some of the funding institutions on this PowerPoint, but I'm sure that there is a number of funding institutions in this building. And it's not that we ignored to put you, but we avoided to put power sentences. We wanted to have a PowerPoint so that when we actually share, we do not take much time by reading. So this is the funding model where we actually look at grants, donor support for setup. We are actually looking at funding from institutions like the World Bank, JEF, AFDB, which is the African Development Bank, and also we actually considered some annual subscriptions by member states. Why did we actually put this into consideration? It is good for the member states to also participate in the infrastructure that we have as a region, so that they take ownership of the infrastructure and make sure that the infrastructure is maintained properly, and we are actually having proper monitoring of our groundwater resource. So for a project to be successful, it needs a number of team members that will actually participate in different roles. And this table shows a number of project team members that we considered for this project, which include a resource mobilization officer, and also we need environmental and social safeguard experts. Why do we need this expert? It is really important that we consider the impacts of the project in terms of environment, in terms of the social, and also aspects to do with governance. It is really important. And then, of course, hydrogeologists, since we are actually trying to monitor groundwater. Of course, probably in the long run, we'll be actually considering also to integrate surface water, since we are looking at managing all our water resources. And of course, we'll be having software developers, data analysts, and of course, project manager will be looking also the whole project implementation. Yes. So what are we saying? We are saying let's actually work together and move from data gaps to data diplomacy, so that we create a single trusted source of truth, which is the platform that builds trust, strengthens water diplomacy, and provides clear base for policies. And of course, the stamp print is actually considered to be the pilot, but we are considering to say all nations that are sharing transboundary aquifers will actually be considered in terms of implementing this project, so that we monitor our water resource. So what is our request? Our request is that we are requesting funding, partnerships, and of course support from GMI, which is already supporting us in terms of giving our innovations and ideas, and we truly appreciate their support. They are also considered us to be part of this conference, learning from experts and also interacting with like-minded individuals. So thank you very much. Maita Basa Inshona from the Zimbabwean language, Engosi Tangi Unen from the Namibian side. Thank you.